14.2, translate and reflect trig graphs. So we're going to look at the translation.
So these notes?
Yes. Of sine and cosine graphs. Y equals a sine of bx minus c plus d, or y equals a cosine of bx minus c plus d are the two things that we're looking at. And a has to be greater than 0, and b also has to be greater than 0. That's from the stuff that we talked about yesterday. So now the difference in our equations is that you'll see that there is a c and a d value. Okay, so c represents a horizontal shift. Left and right. And these move opposite the direction of the sign. So if it is positive, it goes to the left. If it's negative, it goes to the right.
Opposite direction of the sign.
No, I wasn't right.
Huh?
I wasn't finished with the stuff at the top. Sorry.
Oh, I just spelled the sign wrong. I mixed up the N and the G. Same day. That's what I wrote.
All right, D is the vertical shift. Up and down. And this goes the same direction as the sign. So if it's positive, it goes up. Negative goes down. And then the other thing, which I kind of briefly mentioned yesterday, but if A is less than 0, so aka if it's negative, it is reflected.
She was saying like her mom won't let her go home, and I was like, Clara, if you send her a picture of how you look right now, she'll let you go.
Her eyes are like really watery.
Like one eye is like completely red. And I turn around to tell her something. I said, Clara, you need to go home.
Did she not feel good all day?
Yeah, she went to the office.
Yeah, she asked her mom to stay home this morning, but her mom said no because it was just cold. And I was like, Clara, you don't look good.
She keeps sneezing. Her eyes are like watery.
I think it's like the weather. Because like temperature keeps going back and forth between like warm and cold and warm and cold.
Yeah.
And like today's warm again.
64?
All right, now we're going to look at the steps to graph sine and cosine. So yesterday we just looked at the amplitude and period for those, and then obviously for tangent we also looked at the vertical asymptotes. We aren't graphing anything except for sine and cosine. Now, part of your quiz is going to tell you to graph the three parent functions, the three trig parent functions. So that's going to be sine, cosine, and tangent. So those would have been the ones that you had in your notes the other day. So you need to, I would say, I'm hoping that you were careful as you went through and you did them, but you need to make sure that you have all of the scaling correct on your graph with the parent functions, and then also Make sure that you have them like starting in the right place. Make sure for tangent you have the asymptotes in the right place, because those should be like relatively easy free points for the quiz. Because I'm telling you, like, you are definitely going to have those on there. And you'll need them again next year. So put them in long-term memory. All right, so we're going to start with our steps, and then we'll do a few as well. So step 1, using the A value, determine the amplitude. So this part is just review from yesterday, which is the absolute value of A. Step 2, using the B value, find the period, which is 1 full cycle. So that's P is 2 pi over the absolute value of B. Now, I think I said this yesterday too, but a lot of my classes are doing stuff with trig. So the B value, I have pretty much never seen it be negative, but the reason we put the absolute value is just in case it happens to be. So. Step 3. Everybody doesn't teach this step when they teach graphing, but bless you. One of my AP books, she used this method, and I feel like it's really helps people as they're graphing, because if you remember when you did your graphs in your notes for the parent functions, it was counting by pi over 2. So it was like pi over 2, pi, 3 pi over 2. No, you're good. And then 2 pi. You can just set that right there.
I don't really think so.
Kidding.
Anyways, but I feel like it helps like to figure out how to scale it, because they aren't all like pi over 2, pi, 3 pi over 2, 2 pi. Okay, that changes based on what we have. So the way we find that is with this method. So to figure out, oops, if I'm not writing with the eraser, how to scale the x-axis, divide the period by 4. So we would take, for our scale, and this is our scale on the x-axis, it's period over 4. So just to give you a little example, if the period was 2 pi, then I take that and divide it by 4, then I scale it by increments of pi over 2. Okay, or that's how we get like the one for our parent function. That's how they found those. And obviously works in the negative direction as well. Now, if your period is a fraction, so if instead it was like, let's just do this, 2 pi over 3, and then I'm dividing all of that by 4, this is the same as 2 pi over 3 times 1 over 4, so it would be 2 pi over 12, which obviously would reduce to pi over 6. So you'd be counting in increments of pi over 6. So to get 1 full cycle, you go counting increments of pi over 6 until you get to 2 pi over 3, and that's 1 full cycle. It'll make more sense as we do problems. I was just trying to. But anyways, people have found this to be really helpful with how to scale their x-axis, so that's why I teach it this way now. Step 4, using the C value, shift the appropriate units left or right. Again, this one goes opposite the direction of the sign, so if it's positive, we're going left. If it's negative, we're going to the right. Step 5, using the D value, shift the appropriate units up or down. And these ones go the same direction as the sign. And then our final step is to determine whether or not the graph is reflected. All right, so those are all the notes. I'm going to do a few examples not in your book, and then we'll look at some in the book as well. So the C value, just to go back to that for a second, is only if it's like inside of the parentheses, okay? So if instead I have something, well, we'll see it in a second, but just pay attention that the C has to be inside. So if there's no parentheses at all, and you just see a plus or minus, that means it's going up or down, okay? Kind of the same back when we did parabolas, and we were looking at how they were shifted. It works the same way. Okay, so example, f of x is equal to 3 sine of 2x. So this one looks pretty similar to what we were doing yesterday, but we are actually graphing this one. So I'll usually do like my steps over here, and then I'll set up my graph over here, but that's up to you. So step 1 is to find the amplitude. So the amplitude is equal to what?
3.
After yesterday, we should be really good at this. Step 2, finding the period. Period is equal to what?
2 pi over absolute value b, which would be just 2.
So
So
2
we
pi
just do
over
pi.
2. So that ends up just being pi. The next thing is to find my scale. So I'm going to take pi and divide it by 4.
So pi is 4.
So just pi over 4, yep. And then step 4, I'm going to do and 5. Is there anything being added or subtracted over here?
No.
So there's no shifts.
No shit.
So usually if I see that there is something, I'll write out step 4 and step 5 like individually, but since I saw there was nothing, I just wrote it all as one. And then step 6, is it reflected?
No.
Nope, not reflected. So, just for your reference, typically when I'm doing this, if I was graphing this problem, I would mentally check steps 4 through 6, but I wouldn't write anything down. Okay, you don't need to write it if you see that it's not there. I'm just doing it while we're getting used to it, so we're talking through our steps. That way you're used to it. All right, I'm going to set up my graph over here. It's probably not good for you.
It's not.
It's not.
All right, so I count using the scale. I'm going from pi over 4 out to pi. So that's 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, and then 4 pi over 4 is just pi. So obviously reduce them down. And you do need to write labels. I do take off if you don't label them. Amplitude goes up to 3. And also down to -3. Now, if this was shifted, I would obviously need to add some more tick marks on the y-axis if it was shifted up or down. If it was on the x going like, well, left or right, I would need to add some more. But this one's not shifted, so I don't need anything more than these points right here.
That's why it's absolute value, because it goes both ways, right?
Yes.
Oh.
Because amplitude is like, well, absolute value is distance from 0, and amplitude is how far we are from our midline. So this right here is called our midline. So this is a sine function. Sine starts at 0. And then we just follow the pattern. It goes up to our amplitude, back down to 0, down to our negative version of our amplitude, and then back up to 0, and then we just connect it. And make sure it's rounded, it's not pointy, and then you need to draw that it's extending and continuing on. Because this, technically, we are drawing one cycle, okay? But technically, this goes on forever. This is a never-ending graph.
I just want to know how people came up with
Nah.
this.
Gravity. Isaac Newton, man, that stupid apple.
That apple never fell, gravity would never exist.
If he didn't feel like going upside down.
I mean,
Man.
all right. G of x is equal to negative 2 cosine of 1/2 x. So sometimes, just for your reference, occasionally they're going to put this here like this. If they don't, it's fine, obviously. The other thing that I was going to point out is that sometimes, let me go back up here for a second. Sometimes you'll see this parentheses here is inside of, like, between the b and the x, but it doesn't matter. Just different, I mean, well, they do different things, but it doesn't do anything different for what we're doing. So just be aware of that, but it still means that the b value goes with our x there. Okay, so step 1, the amplitude.
2.
2. Step 2, the period.
I need my notes.
2 pi over 1/2, which is what? 4 pi. Then I'm going to do step 3, which is finding my scale, which is the period over 4. So 4 pi over 4,
Pi.
just pi. Those ones are nice. Yep, there's no shift, so I'm going to do step 4 and 5 together. Again, I would not normally write this. I just am for the sake of us getting used to it. And then step 6, is it reflected?
No.
Yes.
Yes.
There's a negative in front, so it is reflected.
That's what
So the other thing I'll tell you with this section is if you want to use colors, you can. Okay. I will use different colors for you to see what's happening as we graph things. If you just use a pencil, that's fine. You just need to make sure that you label things correctly. But I'll show you, even with me using colors, how to label them.
Hey.
Ew.
All right, so scaling in increments of pi.
Sure.
And then amplitude is 2. And again, this one isn't shifted, so I don't need any extra markings on here. If you had an amplitude that was like something really excessive, you could obviously count in increments of like 2 or 3 or whatever.
So-
You just need to, you at that point would need to label those ones.
Instead of it going up from 0, it goes down because it's reflected.
It will, but it doesn't start at 0. This one's cosine.
Oh.
All right, so cosine starts at the amplitude. I usually say it starts at 1, but I rather say amplitude because that's ultimately where it goes. So it starts here, and it goes down like this. And this is what it would look like. Okay, and make sure that you turn at the top points of your amplitude. Make sure you turn it that it's going back down. It doesn't keep going up. It turns and it goes back and it keeps going like waves. Now, this is my original not reflected graph. Okay? So, when I reflect it, I take every point, is where geometry is coming back, and I flip it over the x-axis. So, if this point is at positive 2, then my point actually goes to negative 2. Now, on the x-axis, they stay there. This point that's down here at the amplitude goes to the top amplitude. It comes up here. On the axis, it stays. And then this one goes down here below. So now my graph looks like that. So if you're using colors, you still need to label this, but where the one is that's your final answer, you need to write the word final. If you're using different colors, you can come over here and do a little something like this and write final, something that I can tell which one you're intending to be your final answer. Okay? Now, if you get to the point after we've done a bunch of examples, you've done a bunch on your own, that you feel confident enough, a lot of times what I will do is I won't even graph the original function. I will start with my reflected one if it's reflected. I will always reflect first, even though that's step 6, before I shift a graph, because it's a whole lot easier to reflect than to shift than reflect. Okay, because then you have to find the midline and it's shifted and all that, and it just gets more complicated. Okay, but for the sake of what we're doing right now, I'm pretty much always going to start with the original, then I'm going to reflect, then I'm going to shift all in one step. So steps 4 and 5 will happen at the same time in a graph when we get one that does that, if it has both types of shifting. Okay? Questions about this one? Okay. H of x is equal to 3 cosine of x plus pi plus 1.
C is
Wow.
Okay, step 1, amplitude.
3.
Amplitude is 3. Step 2, period is
1. Pi over 2.
2 pi over 1, or just
Wow.
2 pi.
Yeah.
So if there's nothing here, there's just an imaginary 1 written there.
Shift is up.
iPad is very warm. Step 3, we got to do our scale.
Oh, no, that's next.
So that's 2
1.
pi over 4.
Which reduces
Pi.
to
How am I supposed to?
pi over 2.
And now it's up.
Now, the scale's not something I'm going to, like, if you forget to write it over here, it's not like I'm going to take off for it. But if you have the wrong scale on your graph, I am going to take off for that. Step 4 is the shift inside the parentheses.
Pi?
So if
Which direction?
Left.
Yep, opposite the direction of the sign, so it's going to go left pi. So something just to make a mental note here is it's not just going left one spot because my scale is pi over 2. It's actually going left 2 spots when I mark my graph. So just make sure you pay attention to that kind of stuff. Step 5, is it going up or down?
Up 1.
Up 1, so it goes the same direction as the sign for this part out here. And then is this one reflected?
No.
Nope, so usually I'll do this one like this. So normally if it doesn't have anything, like if it's not reflected, I don't write anything, I just would stop there.
Plus 2.
Alright, so
She used a whole box.
Well, not a whole box, but the rest of it. I'm about to go grab a tissue.
You never finished a box of tissues before.
huh?
Do you need more tissues for Jake? She's
Yeah.
so she's not going home. Why?
She said just use the one.
She probably like this is a fever or something.
I get to go home whenever I ask.
Poor Claire. This is so thick.
So new.
Claire will probably say,
She had Miss Patton's box on her desk too.
"Oh, Claire, I don't know."
And can you serve me some?
Alright, so I'm going to write out my scale here. Now, I see that I'm going left pi, so that means I'm also going to need to put some markings over here this time. It's also being shifted up, so that means I'm going to add some extra marks here. So, over here, pi over 2, pi, 3 pi over 2, and 2 pi. So these are like your normal markings on your parent function. I'm going left pi, so that means I need to go over here to negative pi. Now, I see that it's going up 1. My amplitude is 3, so on the y-axis on top, I need to at least put one more marking. I just liked it even, so I added one to the bottom also, but... Alright, so my initial graph is obviously just like what the parent function would look like. It's cosine. It starts at the amplitude, which is 3. So I'm up here, and then we come down to negative 3, back to 0, and then up to positive 3. So now, you can do this in individual steps, but I feel like you like to save, some time. So I go ahead and translate both things at the same time. So I'm going to start here. I'm going to do my points in order. I'm going left pi, which is, again, 2 spots. So it's coming here, and it's going up 1. This point here, left pi, that's up 2 spots. So it's to negative pi over 2, up 1. Over here, left pi, up 1. Left pi, up 1. And then left pi, up 1. And then now, there's my graph. And then either, again, over here on the graph, write final, or if you're using colors, you can do a little squiggly and tell me which one is the final one. Now, one other thing here, we'll have one like this later probably, but one other thing with ones like this is that they could write it, and I say this because pre-cal had one like this on their quiz the other day and it threw some of them off. It was written like this.
Oh.
Okay? And they told me, a few of them, that the amplitude was 1. The amplitude is always the number that is touching the trig function. So if it's written like this, the first thing I would do is rewrite it and move the 1 to the end, because a lot of them forgot to shift it up 1 or whatever the number was on theirs because they weren't paying attention to that, and so they did it backwards. Okay, so just make sure you watch that. Okay, getting into the actual book problems now.
Yippee.
12. Y equals sine of 3x minus 4. I always know now when somebody uses hand sanitizer.
It smells good.
Yes. It's funny, like, I like the smell, but it's really strong if I use it on my hands. Like, somebody gave it to me, and so I was like, oh, well, I'm out of hand sanitizer. I'm just going to, like, throw this over here. And then people are like, oh, it smells so good. And I'm like, it doesn't, but it stays with you, like, all day.
Exactly.
Okay. Step 1. Amplitude is, 1. Period. I don't know why I just wrote that. Hold on. Try again. Step 2. And also, if you don't write the words like steps, like as long as you have everything, I'm not taking off for that either. Period is what? 2 pi over 3. Scale. So 2 pi over 3 all over 4. When it's a fraction divided by a number, it's the same thing.
Pi over 6.
Yep. Like, I feel like this is like the one that I did earlier, even though I didn't know this one was going to be.
I know.
So that ends up being 2 pi over 12 or pi over 6 when you reduce it. And then,
Down.
yep.
I thought you just said down boy. I was like, what?
So there's no step forward, there's no parentheses, so it's not moving left and right, but there is a -4 outside of it, and so it is going down 4. And is it reflected?
No.
Nope. So notice if there's something that's not happening to it, I just skip that step. I don't even worry about it. So I've got pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3. So your last number that you write down should always be whatever the period was. The first one is obviously your scale, and then you just have to count and then reduce them if needed. This one doesn't go left or right, so I don't need to add anything else. Amplitude is 1. But I see that it's going down 4, so that means in the y-axis I need to go down to -5. So this is a sine function, so where does it start?
0.
Starts at 0, and it goes up, and then comes back down.
The amplitude's 1.
So then at this point, every point is going to get shifted down 4 spots. So this first one is going down to -4. The next one's going down to -3. The next one's going down to -4. The next one goes down to -5. And then the last one down to
How many
-4.
spots?
4. So, final.
It is February.
February.
It is.
I used to go to Miss Patton's
She's
class.
singing
Hey.
jingle bells.
It's not gonna be
That's pretty
good.
close.
That's you.
We're only 10 months away.
Is it? Mine. That's the only stuff.
Mariah Carey.
That's
breaks
jingle.
out.
Wait, what did you say about
You know, surprisingly, this Christmas I didn't hear a lot of Mariah Carey.
Yeah, because every time I heard it start off the radio station, I just instantly turned it off.
Probably like a
You're talking as if you were in
You
the
wanna
car
be?
with me.
Y'all were always
I
together.
Apparently, according to him, we were always together.
You just didn't know he was probably have like a
Yeah,
All right.
He was in my truck.
I'm going to jump down kind of a lot since we've already done several examples to number 30.
Wow. I enjoyed it.
F of x is equal to 1 minus 3 sine of x plus pi. This one will probably be our last one for today. A few things we might finish up tomorrow in this section too. But
Amplitude is
Oh,
3.
federal.
yep, so first thing I would do probably is rewrite this, or at least like cross this one out and write the +1 over here so that I don't get confused about it. Because like I said, it doesn't matter how many times I warn about it. Pretty sure I warned them about it in pre-cal, and some people still missed it. So amplitude is 3, period.
It would be negative. Oh, wait, that's fine.
Excuse me?
What?
Shut. 2 pi.
Just 2 pi. So then the scale,
Or 2.
Yeah. It's
Yep.
2 pi.
2 pi over 4, which reduces to pi over 2. All right, and then is this one being shifted at all?
Yes.
Up 1.
Left pi. Left pi.
Oh, yeah.
Left pi and up 1. It doesn't matter which order you write them in. I just notice I'm not even writing steps. I'm just writing all the things down. Did I hear something else about this one?
Reflective.
Okay. I thought somebody said it, but I wasn't fully paying attention. All right. I'm going to try to do this one where I show you the reflected originally so that you don't have to have 3 separate things drawn on here. You can just have 2.
3.
Okay. Because if you drew your original and your reflected and your shifted, then you'd have 3 on there. But I usually draw my reflected right away. I don't usually write the original and then reflect it. I usually just go straight to it. So I'll show you what I'm doing with that. If that confuses you, feel free to draw them all out. It's up to you. I just know that if you like to shortcut the process, it's nice to have that. All right, so again, I see that my scale is pi over 2, but I'm going left pi, so that means that I need to have 2 spots for it to go over. So I'm going to have 2 on the left, and then obviously my normal 4 on the right over here. So I've got pi over 2, pi, 3 pi over 2, 2 pi, minus pi over 2, minus pi over here. Amplitude is 3 and it's going up 1, so I'm going to need to have 4 on the top. And 4, or well, I just like to make it look even.
Oh, this is big graph.
This big graph.
Okay, the first thing I'm going to do is reflect. So normally sine starts at 0. Well, it always starts at 0. Oh, that's not the right color. Try again. Sine starts at 0 and goes up. If it's reflected, it means it goes down. So at pi over 2, it's at negative 3. Then it would go up. So at pi, it's 0. At 3 pi over 2, we're up at positive 3. And then at 2 pi, we're back at 0. So again, this is my reflected one. Okay, I did not draw the original. If you wanted to draw the original, you could. So now, I've already taken care of that part. So now I just need to do the shift left pi up 1. So every point's going left 2 spots and up 1. Left 2, up 1. Left 2, up 1. Left 2, up 1. And left 2, up 1.
It's okay to not be okay.
Oh my gosh.
So my red one is my final one. Now, you don't have to write the word reflected by yours. I just did so that you could see if you went back.
What makes it start at 0?
Because what's the sign of 0?
Really?
What's the sign of 0?
0.
I don't.
If you ever forget where sine or cosine starts, look at your unit circle. Because what's the cosine of 0? What's the x value at 0 degrees?
0.
1. Cosine starts at 1, or the amplitude. Okay, but the parent function starts at 1. Sine of 0 is 0, so it starts at 0. So if you ever forget, you can use that. The reason that tangent has asymptotes where it does is, again, because it's undefined at those values. All right, we're going to pause there. We might do one more tomorrow, and then there's a couple other things of, like, them telling us information and us writing the equation that are part of this, but we don't have time to do all of that now, so we'll do that as kind of like a refresher tomorrow, and then whatever time is left, that should maybe take us 10 minutes. Whatever time's left, you'll have to work and do problems and stuff, so.